So now that we've talked about direct and inverse variation, we can apply what we've learned to word problems. So there's different situations where you're going to use direct and different situations where you use inverse. If you're using direct variation, you're going to make sure that you're looking for both variables to be increasing. Okay, so as one thing is going up, so is the other. If we're going to use inverse variation, as one variable increases, the other one decreases. Okay, so it can either be the first thing going up and the other one going down, or vice versa. As long as one thing is going up and one thing is going down, that means we're using the inverse variation. Direct variation, they both go up or they both go down. Inverse, one goes up and one goes down. Okay, so let's start with some direct variation examples. The very first one that we have here says the sales at a baseball game vary directly with the number of people attending. If the sales for the game are $12,000 when 800 people attend, determine how many people attend the game. Attend if the sales for a game are $15,000. So this, remember, when we're looking for the missing value, this is basically like the last part of the notes from direct variation, where you need to find that missing value, so you're setting up a proportion. The first thing we need to figure out, though, is what our variables are going to represent. Okay, so it is very important that you pick the right variables here and make sure they match up correctly, or you're not going to get the right answer. So this is saying that as more people attend, you make more money. Okay, so you need to think of this logically in your head. So to figure out what should be y and what should be x, you need to think your y depends on whatever your x is. So do the people attending depend on how much money they make, or does how much money they make depend on how many people attend? It should be the second one, because the more people attend, the more money they make. So our total sales is going to be our y, and then our x is going to be the number of people. Okay, so as the people go up, the sales go up. So we're going to go ahead and set up our proportion. Our first set of data is this information here. So I'm going to use that as my first ordered pair. This is my second set of data. So my first proportion is going to be my sales over my people. So 12,000 over 800 equals my other sales, 15,000 over I don't know how many people, so that's x. So now we're solving this just like we did with the very last part of our notes, where you have to find the missing value. We cross multiply and we divide. So if I cross multiply, I'm going to do 12,000 times x and 15,000 times 800. So 12,000 times x equals 15,000 times 800 is 1,200,000. And then I can divide both sides by 12,000. And my x is 1,000 people. So in order for them to make $15,000, they need to have 1,000 people in attendance. Example 2 is following the same lines. It says ounces of medication vary directly with the weight of the patient. If a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? So again, we need to figure out what our variables are. So do the ounces depend on the weight, or does the weight of the person depend on how many ounces of medication they get? It should be the first one, that the ounces are depending on how much the person weighs. Okay, so our y is going to be our ounces, and our x is going to be the weight. So then I need to figure out what my ordered pairs are going to be. And for the first one, I have my 120-pound adult that requires 3/4 ounces of medication. Okay, so I would go ahead and write my proportion and put my 3/4 over my weight. But I want to make sure that the weight is written at the bottom And then I don't want to write 3/4. I want to write 0.75. Okay, so change that fraction to a decimal. All right, and then I'm looking for how many ounces are required for a 200-pound adult. So my 200 pounds goes at the bottom because that's my weight. My ounces, I don't know that, so I'm going to put Y. Okay, again, cross multiply. And then 200 times 3/4 is 150. Divide both sides by 120. And Y should get 1.25 ounces. And number 3, I'm going to have you try that one on your own. Okay, so for number 3, you should have Y is your shares, X is your dividends, okay? So we're going to go ahead and set up our proportions. So there are 5 shares for $12 a year, $12 a year. And then we don't know how many shares for $24. Cross multiply and then divide. All right, let's try number 4. For number 4, you should have had your Y is your acreage, your X are bushels. So you set up your proportion. Cross multiply. Divide. You should get 750 acres. Oop, nope, bushels. Oops. My bad. Okay, bushels. So for number 5, this one is a little bit different than with the first 4. It says the income of the computer analyst varies directly as the number of hours worked. If the analyst earns $256 for working 8 hours, find the constant. So you don't need to do your cross multiplication. You don't got to set up your 2 proportions. You're just looking for your constant. And if you remember, to find the constant, it's your ratio of your Y over your X. So in this problem, your Y is going to be the money, because how much money you make depends on how much you work. So that's going to be the income. And then your X is going to be your hours. So to find your constant, you would just do your 256 divided by your 8 to get 32 is your constant. So you go ahead and try number 6. For number 6, you should have gotten Y is equal to gallons. And your X is equal to minutes. Okay, so 48 gallons divided by 8 minutes equals 6 is your constant. So we're going to go ahead and flip to the back, and we're going to try out some inverse variation examples. So for inverse variation, remember, it is the opposite. Instead of doing our division and setting for proportions, we're just going to multiply our numbers together. Okay, so for number 7, it says time traveling varies inversely with the average speed. If a train travels between 2 cities in 3 hours at an average speed of 65 miles per hour, how long would it take at an average speed of 78 miles per hour? So we need to go ahead and figure out, we have 3 hours, 65, so that's obviously one of our points, and 75, and then the other missing thing. We need to figure out what our variables represent. So in this one, does the hours depend on the speed, or does the speed depend on the hours? Your time it takes depends on how fast you're going. Okay, so our Y is our time. Our X is our speed. Okay, so to set this up, we're going to go ahead and take our first one. Remember, we're multiplying our X and our Y together. And that should equal our x and our y multiplied together over here. Okay, so I'm going to go ahead and solve. And then divide both sides by 78. So my answer is 2.5 hours. Okay, so instead of doing the cross multiplying, we're just going straight to regular multiplying and then dividing. So number 8, it says a company that produces laptops has determined that the number of laptops it sells, or it can sell, varies inversely to the price of the laptop. 2,000 laptops can be sold when the price is $2,500. How many laptops can be sold if the price of the laptop is $1,000? Okay, so as the price goes up, the sales go down. As the price goes down, the sales should go up because this is inverse. So our y value here is going to be the number of laptops, because how many laptops you sell depends on the price of them. And our x is the price. So you should have your 2,000 times 2,500, because that's the price, okay, equals your 1,000 times y. So when we multiply those together, we should get 5 million over here equals 1,000 y. And then our y equals 5,000 after you divide. Okay, and that's 5,000 laptops. Okay, so you're going to go ahead and try number 9. For number 9, you should have had y equals your width, x is your length, and then you go ahead and do your multiplication. And your y value, your width, should be 9. Try number 10. For number 10, your y should be the workers, your x should be the days. So you take your 5 times 24 equals your 15 times y. So 120 equals 15y. Divide both sides by 15, and your y is 8. So there are 8 workers. Number 11, okay, this is another one. We're just finding the constant. It says the time it takes to bake a turkey varies inversely with the oven temperature. If it takes 3 hours to bake a turkey at 300 degrees, find the constant of variation. So we need to figure out what our y and what our x is. Remember, our y has to depend on our x. So does the time depend on the temperature, or does the temperature depend on the time? The time it takes to cook it depends on how hot the oven is. So our time is our y, and our temperature is our x. And remember, for inverse variation, to find our constant, we are multiplying our x and our y. So we are doing 3 times 300 to get 900 as our constant. Okay, so try 12. For 12, your y should be the cost, your x should be the people. To get your constant, remember that's x times y. So you're doing 7 times 42. And 7 times 42 is 294.